Good morning, good afternoon, and good evening if you're joining us from around the world. Thanks for joining us on our first 2021 webinar for renewable energy, where we're going to look at real-time workflows and ArcGIS philosophy. So joining me today is Alessandra and Scott. I'll be the host. My name is Jeff Allen. I'm the industry lead for renewable energy. Alessandra is our subject matter expert and account executive, and Scott is from our solution engineering team and focuses on renewable energy workflows. Before we get started today, just a little bit of logistics. You have a control panel for the GoToMeeting experience. You can expand or collapse that control panel to move it out of the way so you can adjust your view. We also have a Q&A panel, very important. Please ask questions along the way. We'll try to get to as many questions as we can, and those questions we can't answer live on the broadcast today, we will follow up with an FAQ posted online for everybody. Just a reminder, the webinar is being recorded, and we'll send out the webinar after the event so you can share it with others in your organization. And with that, I'll hand it over to Alessandra for the content. Alessandra?
Yeah, thank you, Jeff. So last year in our renewable energy webinars, we really focused on the idea of building a digital twin for natural and built environments. And these digital twins really provide greater context to solve business challenges by creating relationships and streamlining workflows. And GIS, why we're all here today, is foundational for any digital twin by allowing the interconnectivity of information, systems, models, and behaviors with spatial context, creating a holistic digital representation of environments, assets, networks, and cities. So with the scale of our renewable energy projects ramping up and the need to really stay competitive in the energy space, we need smarter ways to approach the management of our assets to ensure financial success and smooth integration into the grid. And all signs are pointing towards the integration of the Internet of Things, or IoT, as an extremely powerful force we can utilize to ensure this success. So all those IoT sensors continuously collect data to identify and execute the most viable production and distribution strategies, reduce operation costs, as well as predict maintenance needs or prevent costly downtime. And the ability to easily process, visualize, and analyze real-time data feeds together with critical asset information allows us to greatly expand the value of our GIS investments. So the wide-scale use of those IoT sensors, stream processing technologies, and supercharged analytics based on artificial intelligence methods is allowing us to boost efficiencies and better meet customer and regulatory demands. And ArcGIS is the framework to bring these models together and build a more comprehensive picture by integrating that Internet of Things, IoT, and real-time data with your digital twin. So today, we're going to discuss expanding the use of that digital twin we spent all of last year building up in our webinars. We'll talk about steps to easily visualize time-critical data feeds into the organization. And then Scott will showcase renewable energy workflows that leverage real-time and IoT data. And of course, the newest Esri software solution in this space, ArcGIS Velocity. So as I mentioned earlier, there are a lot of real-life concepts that the digital twin oversees. And we want this data to be accessible everywhere. We want to be able to collaborate and have a transaction model so that we can move data in and out of our system. But that digital twin really comes alive with real-time data. And it's about taking our system of record that we've built a step further. So now that we have our assets mapped, we really want to make GIS almost a living, breathing, functioning thing like it is outside of the office in the field. And we do this through real-time analytics. So the question is, how do we make this happen with the ArcGIS platform? In the ArcGIS platform, there are usually 9 common patterns of usage that we see organizations use GIS to achieve. And we've introduced these common patterns of usage before for what we see organizations using. And I expect that many of you probably recognize these patterns. We've showed them a lot. So one common pattern we use is monitoring, so tracking and managing our resources in real time. And we'll often see this pattern of monitoring put together with other patterns. For example, showing a live weather feed to identify lightning strikes or severe weather in conjunction with our staff enabled by field mobility. Or maybe ingesting historical energy output data to identify future maintenance needs, or even real-time data feeds from sensors on equipment, components for asset status monitoring in conjunction with our decision support system like our WebGIS portal or ArcGIS Online. So by bringing all of these GIS patterns of usage together and we can build a more comprehensive solution inside of our technology stack. So what we'll show today is a really flexible and extensive framework that can be configured to support a huge number of use cases to drive our business improvements. So when we put real-time and big data to work for us, we can support fleet tracking, route deviation analysis to make sure we're only driving on the roads that we're supposed to, or maybe work site assessments to reduce operational costs and increase production efficiency, and even enhanced awareness of environmental risk. So in many ways, this is just a really small sample of how these capabilities can be leveraged in our ArcGIS platform. So let's take a step back. When we talk about real-time data, what really makes this data different from the other data we store in our enterprise geodatabase? Well, there are three characteristics of real-time data. The first is velocity. It's, the speed at which the data feeds into our digital twin, and those data sets change rapidly. It's the massive volume that this data feeds in, which is completely unprecedented for what we've seen. And real-time data is highly variable from one sensor to another. The key challenges in meeting the needs of IoT use cases generally fall into three categories. So first is really the need to ingest all of that data being broadcast by our sensors. Then we have a need to process that data in real time to trigger alerts and actions so we can act on that. And then we have the need to store and analyze the massive amounts of historical data in order to reveal patterns over time and provide insights for future decisions. And most of us have heard about GeoEvent Server, which is an extension of ArcGIS Enterprise. So GeoEvent Server has a key few things. One, we can ingest all of those real-time feeds at velocity into the ArcGIS platform. This gives us a common way of bringing in this information without having to manage hundreds of different systems. Once we have that data in, it's important to do analytics. So now that we have the data in, we want to do processing. And once we've processed that data, we want to store this so that we can analyze events in the past and over time. But not just that, we want to visualize this through the ArcGIS platform. So push that out to our Esri mobile applications, dashboards, or web maps. And then in addition to all of this is actuation. So maybe we push back out to our field devices. For example, if we have crews in the field and we have that severe weather alert, we want to let them know as soon as possible to take cover, that something is heading their way. So all of this is a capability of GeoEvent Server. And to look at that data over time, like we mentioned, there are even more capabilities we can add to do analytics on big data storage. So now that you have all of that big data stored, you have real-time analytics happening, now you want to do trend analysis on big data samples. So that is what ArcGIS GeoAnalytics Server does. It ties in the data store and generates other results and visualization of the trend analysis on that big data. When we look at really feeding or ingestion of real-time data into our ArcGIS platform, you can see there are a lot of options here. So first, there are many out-of-the-box connectors that have been written, so GeoJSON, RSS feeds, or you can even build your own connectors. So many of those are built by Esri out of the box, or we have a really extensive partner gallery to ingest all of that into the platform from existing IoT providers. And then we move into processing of those real-time feeds. And again, many out-of-the-box processors that we can use or we can build for these processing capabilities, like geoprocessing tasks within your real-time platform to add value, such as adding buffers around certain areas or having an incident detector. And finally, to disseminate this, once you have that workflow you want to push out, how will you choose to do that? Are you going to send an email out to your field crews or send a text message for a more immediate message? There are several dissemination methods to alert and inform of real-time workflow information. So there are really two key patterns here. One, we can either feed data into our platform, process that data, and then perform real-time analytics, then disseminate this through feature layers, notifications, or actuation. Or we can ingest all of the data, perform real-time analytics on the data, store it over time, and then perform near real-time or overtime analytics on the data and see what happened, last week, last month, or even last year to pull value analysis out of the data over time. Again, putting all of that data to work for us. So this brings us to ArcGIS Velocity. And we now have all of those capabilities we just summarized to deploy this ability in real-time data in the cloud. So ArcGIS Velocity is a new capability that extends Esri's geospatial cloud with real-time and big data functionality. So as a product, ArcGIS Velocity is implemented in the cloud as software as a service, or SaaS. And one of the key differentiators here is its scalability and resiliency. So under the hood, it runs on Kubernetes, which is a container-driven architecture. And this really enables it to scale because, it can compute and be distributed across parallel tasks, and to be more resilient because those tasks that encounter issues can restart and take off from where they left off. And it's fully managed by Esri, which takes away all the complexity of configuring and maintaining a suite of on-premise servers. And again, we've always had the ability to deploy real-time data on-premise with GeoEvent Server. And it is cloud ready, meaning we can deploy in AWS or Azure environments. But ArcGIS Velocity is cloud native, and it was built on the idea of running in the cloud first. So many of you today may be familiar with all of that real-time and big data capabilities of ArcGIS Enterprise, GeoEvent, and GeoAnalytics Server, which are the two primary products that allow you to bring and analyze voluminous data streams. ArcGIS Velocity, again, is parallel to those products in the cloud. So it has GeoEvent's capabilities for real-time incident detection and alerting, and geoanalytics capabilities for big data summarization and analysis. So again, the key differences here, other than being a cloud native service, are the speed and the volume and reduction complexity and maintenance as a SaaS product. In return, ArcGIS Velocity really provides that flexible and extensive framework that can be configured to support a huge number of use cases to drive business improvements in our organization. So as you saw, those feeds and analytics can be combined in various ways to support fleet tracking or make sure our employees and contractors are safe when they're out of the office. We can do route deviation analysis, which improves the safety, alert of severe weather events or potential impacts on our assets. Maybe worksite visits analysis to reduce the operational costs and increase production efficiency, or enhanced awareness of environmental risk. And in many ways, this is just a really small sample of how these capabilities can be leveraged. So today we're going to show you some examples of that. And there's a lot of additional capability here. So next, Scott's going to walk you through a few examples on big data analysis, both in terms of scheduled processing as well as ad hoc pattern analysis.
All right, thank you, Alessandra. So to illustrate some examples of how real-time data can be integrated into your everyday workflows, we're going to focus on 3 key use cases that are specific to the renewables industry. The first use case here is asset performance monitoring. What we've got here on the screen is a map of our wind farm in the Kansas region. And we've got some typical operation layers added to this map. So we see our wind turbine locations, our collection system, maybe our lease roads, and more data that helps us paint this operational picture. If we zoom in here on the map and click on one of our wind turbine locations, we can see some of the detail that we're collecting and storing in the GIS. And this information is very useful, but it's static. This makes it challenging to understand current operating conditions in the context of the real world, really, creating that digital twin. And in order to build that true digital twin, we need to enrich the static GIS data with dynamic information about the real world. Now, these wind turbines are monitored by a SCADA system that reports real-time operating conditions and equipment status. So being able to connect this dynamic sensor feed to our static GIS data will transform the static map into a live view that updates in real time. But how do we get that dynamic data into our GIS system? That's where ArcGIS Velocity comes in. So as Alessandra mentioned, ArcGIS Velocity is the real-time and big data processing and analysis capability of ArcGIS Online. It's completely hosted in the Esri cloud and available as SaaS, which means it can scale to meet your needs. There's really three kind of key components of Velocity. And here on the home screen, we can see what those three components are. So the first is feed or feeds. Feeds connect external data sources to stream data into ArcGIS for visualization and analysis. Real-time analytics perform processing on data that's ingested through a feed as the data is received. And big data analytics perform batch analysis on stored data, either on demand or at scheduled intervals. So here within my Velocity homepage, I can see recent activity about existing feeds and analytics, but I can also create new workflows as well. So to get started, we're going to create a feed. And there's several different feed types you can create within Velocity. So you can connect to data that's already within ArcGIS or an ArcGIS format like a feature layer or a stream layer. You can connect to various cloud data stores like Azure, AWS, and Cisco. And you can connect to your data through a variety of standard web messaging protocols like HTTP, Kafka, RSS, WebSocket, and more. In this particular use case, our SCADA system happens to be writing to an Azure Event Hub. So we're going to use the Azure option here to connect to our SCADA data. We're going to configure our connection first before data can be streamed in. So we're going to provide a shared access key name from our Event Hub instance, a shared access key. We're going to specify our endpoint here. Get the right one. And then we're going to provide the entity path. So Velocity is going to validate all of that connection information. And then what it's going to do is auto-discover the schema of the data that we're connecting to. So this is the actual information that's being stored in the SCADA system. And we can get a preview of that data here so we understand what type of information is going to be flowing into ArcGIS. So we see we've got information about our wind turbines, and then real-time information about wind speed, maybe wind direction or yaw direction, power output, air temperature, rotor RPM, and more. So these are some of the feeds or data sources, or excuse me, data points that we want to bring into ArcGIS to do visualization and analysis. And I can come in here and I can update this or choose to, add or remove certain fields if I want. The next thing I'm going to do is specify some location or some key fields. One of those is location. So if your real-time data has location or a spatial component tied to it, you can go ahead and specify that. Or you can specify date and time fields. In this case, we've got a timestamp that indicates the time that each value is being collected. And then we can also associate what's called a tracking ID. And this just allows Velocity to identify unique values that are coming and being ingested in our data stream. Our last step here is going to be to just create the feed name. I'll just go ahead and give that a name and an optional summary, and I'll go ahead and complete. So on the back end, that feed is being created, the connection to the source data is being established, and then it's going to initialize. So here on my feed details, I'm going to get some overall information along with the schema, the output schema that all my information is going to be written to. So now that we have a feed, we can start to work with the data in the context of ArcGIS velocity. Now, since this tabular data, or since the SCADA data is tabular, we want to be able to marry it up to our static wind turbine features that are already existing within a layer in our GIS. So to do that, we're going to use a real-time analytic. And again, real-time analytics are ways that you can bring data in or connect to data that's being brought in and perform real-time analysis so you can output data for visualization. Here I've already got an existing real-time analytic that's been built. Just in the interest of time, we'll go ahead and open that up and see what it looks like. So real-time analytics allow you to do a couple of key things. And the view here is very similar to what you might expect in something like Model Builder. So I can come in here, for instance, and input or add my data that I want to be able to analyze through either a feed or a source. And then I have different sets of tools that allow me to process that data based on the type of analysis I want to do. And then I come in here and I can configure an output to either write that layer or that data to a new layer or send an email or perform some type of actuation or alerting. So this particular analytic is pretty simple. It's connecting to our wind turbine SCADA. It's, oh, sorry, go back here. All right, it's connecting to our wind turbine SCADA feed. That's bringing in all of our information, and it's joining that real-time feed to our existing wind turbine features in an existing layer. Now that output is being written to a new feature layer that's going to be stored within our ArcGIS online instance. And the join here, we can see some information about what join is actually being configured or performed, and we have the ability to come in here and specify all this information. So this is just using an attribute join by targeting a unique ID within both the incoming SCADA feed and the existing GIS layer. So it's really that simple. I would come in here and save this and then start this feed to start ingesting my data in a format that I can then work with. So back in my map, since the output of that analytic is a feature layer, I can actually come in here and add that layer to my map. So there's our wind turbine SCADA layer that's been created as an output from that analytic. And if we look at it here on the map, we can see the information coming in real time. So instead of just our wind turbine static attributes, we have now our dynamic attributes like our power output, rotor RPM, turbine status, wind speed, yaw direction, and more. Now, visualizing this data on a map is certainly helpful, but it still doesn't allow us to fully understand the operational status of our wind farm as a whole. Now, luckily, we can leverage the other capabilities of ArcGIS to create a more tailored information product. Here I've got an operations dashboard that's been configured to show metrics as they update in real time. On our map here, we have each of our wind turbines that have been symbolized by their status. So I can quickly see which wind turbines are online, which ones are offline. And I've got some different visual elements around this dashboard to help me better understand the real-time performance and conditions. And this dashboard is also interactive. So I can come in here and select any of these individual wind turbines and get specific metrics on the performance of those, as well as see performance overall of my wind farm overall. And then different graphs and charts will help me visualize things like power output over time and how that compares to current power output. So this dashboard, is really beneficial in creating kind of this common operating picture, and it's something that could be accessed by remote staff. So if you've got a remote operations control center or someone back in the office that wants to view this information, we can take that data and put it in their hands regardless of where they are. So the concept of this digital twin really extends beyond just assets and equipment. They can include people and resources too. Now, the second use case we're going to look at today focuses on personnel safety and compliance. Renewable energy projects are typically located in these rural areas. And there's an enhanced focus that must be placed on worker safety and compliance in these rural areas. It's important to understand where workers are and ensure that how they are working is in accordance with company policy and safety practices. Now, not all project sites are equal. Here at the same wind farm we just looked at in Kansas, there isn't a whole lot of activity going on. If we look at the base map, the aerial base map here, we can see there's a lot of kind of agriculture and a lot of kind of local landowner use. But other than that, it's pretty quiet. Now, in other parts of the country or around the world, this isn't always the case. I'm going to zoom to a wind farm here in West Texas that paints a completely different story. So if you know West Texas, you know oil and gas is kind of king, but there's also a budding renewables industry with a lot of wind and solar development in recent years. Now, if we zoom into our wind farm project here, the landscape tells a completely different story. We can see a lot of well pads and oil and gas lease roads. We can see pipeline right-of-ways. We've got a bunch of public and private roads. So all of this really adds complexity, along with the increased activity from other industries in the area. This can result in numerous operational challenges. For one, it can make navigation in the field more difficult for our field workers. For instance, we may have approved roads that all of our workers can drive on. And looking at this imagery-based map, it can be really easy to drive down the wrong road or not fully understand what road you need to be driving on. It's also important from a safety and legal perspective, making sure you don't accidentally go on the wrong piece of property, making sure you stay off of lands and roads that you're not supposed to be on, maybe having to pay damages to landowners, or even increasing the chance that our workers might get in an accident. So all of these are different factors that kind of play into this complex operational picture. Now, real-time data from the field can be used to help overcome some of these operational challenges by providing enhanced situational awareness. So back in Velocity, we're going to look at a feed that's been configured to connect to our real-time worker locations. So here I've got a wind farm location tracks feed that's already been created. And if we look at this feed, we can see that it's streaming in information from devices out in the field. These could be phones or tablets that are capturing worker locations, or it could be something like a vehicle AVL feed. So we're ingesting those real-time worker locations from the field, and we want to use those worker locations to detect potential safety and compliance violations. So to do that, we're going to use another real-time analytic. Again, in the interest of time, I've already built one out here, and let's walk through what exactly it does. So it takes our existing location tracks feed, and it outputs a last known location layer that allows us to visualize at any point in time where a field worker was last detected. What it's also doing is calculating the distance from the detected location track of each worker to the nearest approved road. And if we look at our next tool here, we're running a detect incidents analysis to understand or identify any potential location that is greater than 250 feet away from our approved roads. So if a worker deviates more than 250 feet from a road that they're supposed to be on, we'll be able to provide a notification and actually store that information for historical analysis. So out of that detect incidents tool, we're going to update the status of our workers. And then we're also going to log all of those location tracks that are being collected that don't fall within that approved distance of an existing road. And then finally, we're going to leverage some of the alerting capabilities of Velocity to send a text message to our workers in the field, specifically those that are in violation of that approved distance. And we can come in here and specify the exact message that we want to send, as well as code some information that is going to allow us to send that message from a trusted source. So once I've configured my real-time analytic, I'm just going to come up here and start this. Now, while that initializes, I'm going to go back to my map, And let's look at one of those input layers. So specifically, I want to bring in my location tracks layer. So this is the feed that was created that's streaming in the real-time locations of our workers. And this will allow us to see in real time where our workers are here within the context of our map. Now this is a stream layer, which means it's constantly being overwritten with the latest values. So if I zoom in here, you can actually see when a worker moves, that position there on the map will update. And the way this layer has been symbolized, apologies for my slow connection here, the arrow is indicating the direction of travel of the worker, and then we've got a little trail of points that show where they've been. So just visualizing this on the map already provides us with some additional context and lets us understand where our workers are in real time. But for that next level of insight, really understanding how our workers are performing, we want to be able to create a dashboard that helps paint that story a little better. So here in this dashboard, we've got some additional information. One, we've got that same map on the back end. And then two, we've got some information about all of our active personnel. So all of our individual drivers, some contact information, and when their feed was last updated. So since I just ran that analytic and started it a minute ago, what's happened since that analytic started is that information is now being captured. So we can see right here, Bill Young is actually driving on an unapproved road. And that activity has been logged here in the dashboard. So we can see exactly when that deviation started, and in this case, how long it lasted. All of that information that's being captured in terms of location tracks are also being stored. So we could use that to go back and do a historical analysis. Over here, we're also looking at our current deviations. So if a worker, like we see here, John Brown, we can see here his distance from the nearest feature, approved road feature, is actually being updated as he drives either further or closer from that road. So we now have a very good picture and understanding of where all of our workers are in relation to where they need to be. Also on the back end, these drivers that are deviating from our approved roads are getting a notification via text message to say, hey, go back to our road, you're not on an approved road. Now all of this is being done in real time. But Velocity, as Alessandra mentioned, also has the ability to store data and perform historical analysis. So if we turn off some of our real-time layers, let's look at some historical location tracks that have been collected over time. So these represent essentially a lot of breadcrumb data over time that has been captured and stored to show where workers have gone over the past month, 6 months, or year. Now, to be able to actually visualize this and get meaningful information from it, we can run tools that aggregate all of these historical tracks. This helps us visualize from a much cleaner perspective where areas of high activity are occurring. So all of my darker figures here represent areas with much more activity. And that activity may result in quicker damage to roads. So we may feed this into some preventative maintenance model that allows us to target areas to focus maintenance on and ensure that all of these stay in compliance with different agreements we may have with landowners, or to increase the overall safety of our workers as they travel in the field. So the value of enhanced situational awareness delivers, or the value that enhanced situational awareness delivers, really extends beyond assets and people and into the natural world as well. So there's a variety of natural phenomenon that occur every day around the world, and having the ability to monitor these occurrences and the impact they have on your assets and people, and the resources, the ability they have on your assets, people, and resources is vital to mitigating risk. Our third and final use case here that we're going to look at today focuses on risk mitigation with real-time data. So this map that we're looking at here, we're going back to our wind farm in Kansas, and we're showing basically how geography can play an impact and a role, or play a role and have impact on how our assets are impacted by external forces. So if anyone's familiar with the Western Kansas area, you know how wild the weather can be. There's severe thunderstorms, there's high winds, hail, blizzards, tornadoes. All of that's possible in this region, and it really poses an enhanced risk to assets and resources. lightning in particular can be particularly dangerous because it can strike quickly and with little warning. So what I've done here is added a layer that shows all of our aggregated historical lightning strikes for 2019. And we can see here on the map that our wind farm is just on the edge of some very enhanced activity. So lightning is very prevalent in this area and is a risk that we need to be aware of. Now, we may not be as concerned with historical lightning, but we definitely want to know when lightning is occurring and how it's going to impact our assets. To do that, I've also added a global lightning layer into our map that allows us to visualize real-time lightning observations as they're occurring. Oh, I turned it off. Let me turn it on. There we go. This particular layer is provided by DTN, which is an Esri partner and a leading weather content provider. DTN shares their data as web services, which means you can seamlessly stream live weather layers directly into your map and get updates in real time. So all of these lightning strikes here have occurred in real time and are being tracked and stored by the DTN and made available in a format that you can easily consume in the map. Now, if we zoom back into our wind farm, we're not necessarily concerned with global lightning activity, but we are concerned with lightning that occurs within the vicinity of our project. So here I've got a series of buffers that have been created around our wind farm. And really what we're interested in is any lightning that occurs within any of these buffers. And we want to be able to detect that lightning so that the proper precautions can be taken around our operations. Again, this is where ArcGIS Velocity can come in and help give us the information we need to perform this type of analysis. So back in Velocity, since the lightning data from DTN isn't technically real time, it's being updated every minute or every couple minutes, instead of a real-time analytic, we're going to configure a big data analytic. And here I've got an existing analytic that we can look at and see what we're doing to actually process some of this information and get a usable output. So big data analytics are configured almost the same exact way as real-time analytics. You have access to a lot of the same tools, but the main difference is that you can schedule big data analytics to run at specified intervals, or you can run them manually. So at a high level, what this analytic is doing is it's taking in our lightning strikes that are being updated, and it's taking in our project boundary buffer that we just looked at. It's projecting those two layers into a common coordinate system, and then it's performing a spatial join to detect lightning in the vicinity. In this case, we're doing a spatial relationship. Any lightning that intersects with our project buffer boundary, we are going to create an output field. And in this case, we're really only concerned with cloud to ground lightning. So we're actually going to filter out all of our cloud to ground lightning based on the attributes that are being collected by DTN. If lightning does get detected in the vicinity, an email is going to automatically be sent to our project foreman or supervisor, alerting them that lightning has been detected. What's also going to happen is that the distance from that detected lightning strike is going to be automatically calculated to the nearest wind turbine asset. In this case, we're only interested if lightning is within 15 miles of any existing wind turbine. And if it is, we want to be able to output that layer so we can map it. And we also want to be able to alert our field workers in the vicinity that lightning has been detected. So up here, we're using the calculate field tool to actually take some information like the observed time, the distance from the lightning strike to the closest feature, and the impacted wind turbine name. And we're configuring a text message that we're then going to send through our text output. So there's a lot going on in this particular analytic, but it all gets done seamlessly and in real time whenever the analytic is scheduled to run, or if I manually schedule it to run. So we'll go ahead and start this and see what the output looks like here in a few seconds. And I got an error, but that's fine. Let me go back, try to run it from here and see if that works. All right, while that's spinning up, let's go back to let's go to a third dashboard here and see how we can integrate all of this real-time weather information into a common operating picture. So here I've got a map that shows, again, our Kansas wind farm centered here, but I've also got some existing weather stations in the current extent around our wind farm. And this is going to help me understand the current weather conditions in the area. And I can click on any of these weather stations here and see where they're at on the map. And this layer here is another real-time weather layer coming from WTN. So besides just lightning, or DTN, besides just lightning, they have a bunch of different layers that you can stream into your map and use for real-time visualization and analysis. Over here on my left, I see currently detected lightning strikes. Now, there's not a whole lot going on in the US right now. If we zoom out, we can actually see we do have some active weather watches and warnings. Again, another layer coming from DTN. And if we zoom out a little further, we've even got a live weather radar. So all of these layers are being streamed in, adding context and information to my map. And I'm able to really understand what the current conditions are out there in the area of my project and in the region or any region that I'm interested in looking here in the map. And we can view all of our watches and warnings here, see specific information about what they are, and our active weather radar as well. So since there's not really a whole lot of active weather going on in our wind farm, in order to kind of demonstrate the capabilities of velocity, we have a simulation that we ran. So if I come over here to our second tab and turn on our static weather radar, we can see we've got a simulated storm that's encroaching on our project here. Along with the storm, we've had a few detected lightning strikes. So if we toggle on that buffer, that AOI that we looked at, we can see exactly which one of these lightning strikes fall within each of those buffers. And our dashboard has a couple of elements that help us roll up and report these important metrics. So I can see exactly how many lightning strikes are within 5 miles, 15 miles, and 30 miles, which corresponds to each of these buffer rings here. What I'm also getting as an output from our big data analytic are some specific instances that tell me exactly how far lightning strikes are from existing assets. So in this case, I can see this close lightning strike here within 15 miles is actually 10.87 miles from our T38 wind turbine. I can see our other wind turbine, our other detected lightning strike here is about 16.3 miles away from T19. So now I can pinpoint the exact asset or group of assets that are going to be impacted by, in this case, lightning or any weather phenomenon that's being observed. Now on the back end, we also had a few alerts that got generated. So if I open up my email here, I can see I just got an email here that was sent 3 minutes ago that was automatically generated saying that lightning has been detected in the vicinity. All field workers within 15 miles of that detection strike will be notified immediately by text message to seek shelter. So someone in the office or someone in the field may get this email, but we also want to alert all of our field workers as well. And if I drag over my phone view, I can see I just got a text message with an alert that has a timestamp. A lightning strike was detected, again, that same distance from that same impacted wind turbine, and I can go ahead and seek shelter and wait out the storm as it passes. So there's really a lot of capabilities you can do here to alert and notify individuals based on the occurrence of some observed criteria that we're analyzing or creating there within the velocity analytics. So at a high level, right, those 3 workflows that we just looked at are just a few examples of how real-time data can be integrated with your GIS to create a digital twin. And the world is full of connected sensors and IoT systems, so the possibilities of what can be done are really endless. Velocity enables you to operationalize all of that real-time data that you're collecting and enhance situational awareness and decision support to ultimately drive value within the organization. Alessandra, I'll toss it back over to you.
Yeah, thanks, Scott. That was awesome. I always love your demos. It's a lot of fun to see the technology in action. So again, to recap, we always do this with our webinars. We want to show you what Esri technology we use. So today, using ArcGIS Velocity, Scott showed several renewable energy workflows and leveraged real-time Internet of Things data He demonstrated steps to easily visualize time-critical data feeds into the organization and gave examples of various real-time workflows that all of us use today and you have been asking us to show. So, he demonstrated how to configure those feeds and bring it in, visualize the real-time data, and then get those used in real-time analytics for immediate awareness incidents. And real-time analytics can also store observations over time to a feature layer. So as that data arrives in real time, those historical data sets can grow to large volumes very quickly. So even just 250 messages or incidents per second grows to 20 million records within one day. And so that reason is why ArcGIS Velocity was designed. It's designed to grow with you and with all of that big data. And it includes fully configurable big data analytics that you can process this information for trends over time. So these big data analytics can be traditional ad hoc analysis, but they can also be scheduled and run in near real time to support different workflows. So to wrap up our webinar, ArcGIS Velocity makes real-time and big data capabilities available as software as a service in Esri's geospatial cloud, hosted and managed for you so that the automated data ingestion and analysis is easier than ever before. And this, again, enables you to put all of that big data to work for you. ArcGIS Velocity allows you to integrate real-time data, monitor critical assets for 24/7 visibility on dynamic assets that are constantly changing, trigger alerts from analytics to display and share your findings with the organization, and help you work in the cloud with a software as a service or SaaS configuration, and ultimately unlock spatial insights to make more informed decisions. So with that, we're going to wrap up and open it up to any questions we have.
Cool, thanks guys. Scott, maybe you can come back on video and join us. And we've got some really good questions that have come in from the audience. I've been sort of busily typing in some answers here to the obvious ones, but I think we'll start out just as a sense of making the distinction between Geo Event Server and ArcGIS and ArcGIS Velocity. Where is that distinction? If I'm using a Geo Event Server now, do I move to Velocity, or if I'm trying to pick a platform, what would be some of the use cases I would have for choosing between those two?
Yeah, like we said, this real-time analytics, we've had that capability within the Esri software. Like I mentioned, the reason why we went over GeoEvent and GeoAnalytics is because that has existed. And so ArcGIS Velocity is a parallel to that in the cloud. So this is really useful if your organization is trying to get everything off-prem, go fully in the cloud, and you don't have the time or resources to manage that. Esri can manage all of that for you and really put all of those capabilities together and host it in Esri.
Cool, awesome. Scott, the next question is for you. During the demos, you were kind of showing a bunch of different things. Can you kind of differentiate between what was going on in ArcGIS Velocity and what were you showing on web maps and dashboards, and what were those dashboards? How did you create those dashboards in the platform?
Yeah, absolutely. So within Velocity, what we were doing was configuring specific workflows that ultimately had outputs. So an output could be a feature layer, it could be a email or a text message. So depending on the type of output that was generated in the different analytics that we configured, those outputs would then just be added to a web map. And you could take that web map and share it as a web application or a dashboard to create some of those more defined views that had specific metrics around what was happening. So there was a little bit of a process in creating not only the workflows and Velocity and the outputs, but being able to take those outputs and add them to a type of information product that could be ultimately used by someone in the organization or a stakeholder that wants to interact with this information. Cool. And all of the dashboards and web maps and everything that we showed today was completely out of the box. There was no coding or programming or customization that needed to occur. So being able to leverage ArcGIS Online and the ArcGIS platform and all of the configurations and different abilities that you have really helps increase your time to market and helps you deliver some of these things much more quicker than creating something like a custom application with a lot of coding and programming.
And kind of a follow-on question to that, if I wanted to make that data accessible to, say, maybe a customer or a contractor or somebody outside the organization, how easily could I do that?
Yeah, at the end of the day, a lot of those outputs, like a feature layer, for instance, is accessible as a REST endpoint. So you can either share that URL with a user or another organization that has access to that, so they can stream it in to their map, just like we were bringing in all of those DTN web services. Or you can take advantage of some of the sharing models and capabilities that are built into ArcGIS Online and the geospatial cloud to share content securely with users and make sure that people are accessing the information that they need to be accessing.
Yep. And then the other question we got in, Scott, was more around the automation. So maybe you can just kind of to talk about that for a second. You know, I know a lot of the workflows that you showed would be ongoing. They would happen every minute of every day. Is there a lot of user interaction there, or are these really designed to be set up and sort of run unattended on the server?
Yeah, absolutely. So what we showed was kind of the process of building out in the initial phase some of these analytics and workflows. But Velocity is really designed to configure the workflow and then kind of set it and let it go. So you saw on some of those views that we're looking at, some of those control panels that had each of the analytics or feeds, and you can go in there and manually start or stop any of those feeds or analytics at any time. But if you have a real-time analytic that's running and you start it, that thing's just going to keep on working. It's going to automatically run until you go in and stop that analytic or stop the feed that's inputting into it. So it's really designed to kind of set it, forget it, let your data stream in, and then use those outputs that are being generated to have enhanced situational awareness or use it in decision support workflows or whatever they may be.
Cool. And then the other question we got, last kind of real technical one here, is can Velocity be exposed as a streaming layer in the JavaScript API?
So I think what the question is asking, I could be wrong, but it sounds like if you have a custom app that's built using the JavaScript API, could you connect to some of the outputs that are being generated in Velocity? And the answer is yes. You could code or add a layer from Velocity that's being generated as an output and visualize that in any custom map that's generated within the API. It doesn't necessarily have to be an out-of-the-box web app builder application or dashboard. The benefit of Velocity is that it's generating those output data in standardized formats. So just like you could consume an Esri base map or any other feature service or map service, you could take the outputs from Velocity and consume them in the same way.
Cool. And then another question, sorry, Scott, I lied. It's one more technical question. How about what are ArcGIS Velocity's capabilities to interface with Azure IoT services?
So we looked at this a little bit in that kind of first workflow where we were configuring a feed. There's different feed types that you can set up, and there's several different cloud providers that are supported. So we showed connecting to an Azure Event Hub as an example, but there's a few other supported Azure data sources that you connect to. There's Amazon IoT or AWS IoT data stores that you can connect to, and then there's also a Cisco data source that you can connect to. So within the cloud kind of data store area, we support most of the kind of big name out of the box kind of data aggregation sources and databases out there with the big cloud data providers.
Cool, thanks. Alessandra, back to you for our last question. If I wanted to license Velocity or buy Velocity, how does Esri provide this as a software product?
Yeah, good question. So ArcGIS Velocity is a subscription license, and there are actually 3 different levels. So each one is successive and adds more functionality. So it kind of starts at a standard license that's really suited for organizations with lower velocities of data or simple use cases. For example, if you want to track fleet of vehicles and monitor deviation from the assigned routes or areas, all the way up to a dedicated license. So organizations with extremely high velocity of data, multiple use cases, really high volume data analysis requirements. So maybe you want to ingest information from connected cars and use it to generate early warnings of roadway issues or traffic patterns, and then store those high volumes of data to mine for trends. So again, Scott and I are your account team within Renewable Energy. We're more than welcome, or more than happy to work with you to talk about those different levels and really make sure you're getting the right fit and talk about, specific pricing for your organization.
Perfect. Thank you. And thanks everybody for joining us today on our first webinar for renewable energy for 2021. We have a series of questions that will pop up at the end of the webinar. We please encourage you to answer those. Gives us great insight on what things you're trying to do with IoT and helps us help you. But more importantly as well, there's a question in there about other topics you'd like to see. We're trying to do one of these online webinars each quarter, and we'd really like to target the topics that you guys are most interested in renewable energy. And so thanks for joining us today, and we'll post all the Q&A online, and the recording will be available soon as well, and we'll mail that recording out to everybody that registered for the webinar. So with that, thank you for your time. We truly appreciate it, and have a great afternoon. Thanks, guys.
Thanks,
Thank you. Take care.